The music you hear is an AI. My voiceover text is also a product of artificial intelligence. Even me, even my voice. Everything started in 1950. Alan Turing published Computing Machinery and Intelligence, ignited a revolution with a single question: can machines think? His answer, the Turing test, was born on paper. If a machine can fool a human into thinking it's another human, then it truly thinks. Marvin Minsky and Dean Edmonds made history in 1951 by creating the first artificial neural network, ANN, named SNARK. This pioneering technology simulated a network of 40 neurons using 3,000 vacuum tubes. In 1952, Arthur Samuel pioneered self-learning AI with the Samuel checkers playing program, the world's first of its kind. This groundbreaking program marked a pivotal moment, demonstrating the potential of AI in mastering games. In 1956, John McCarthy, Marvin Minsky, Nathaniel Rochester, and Claude Shannon marked a fundamental moment in the field of artificial intelligence by coining the term artificial intelligence at a seminal event, a workshop proposal. In 1958, pivotal developments shaped the AI landscape. Frank Rosenblatt introduced the perceptron, an early artificial neural network, ANN, capable of learning from data, laying the foundation for modern neural networks. Simultaneously, John McCarthy pioneered the programming language Lisp. Swiftly embraced by the AI industry, Lisp gained immense popularity among developers, becoming a cornerstone in AI programming. In 1959, Arthur Samuel came up with the term machine learning, emphasizing the idea that computers could be programmed to perform better than human programmers. Simultaneously, Oliver Selfridge's impressive work, Pandemonium, a Paradigm for Learning, made a significant contribution to the field of machine learning by presenting a model that adaptively evolves itself to recognize patterns in events. In 1964, Daniel Bobrow achieved a milestone in natural language processing, NLP, by developing Student, an early program aimed at solving algebra word problems. Bobrow, a doctoral candidate at MIT, laid the groundwork for advancements in NLP, marking a significant step forward in the integration of artificial intelligence with language understanding. In 1965, a pioneering achievement unfolded as Edward Feigenbaum, Bruce G. Buchanan, Joshua Lederberg, and Carl Djerassi collaborated to develop Dendril, the first expert system. Dendril revolutionized the field by assisting organic chemists in identifying unknown organic molecules. In 1966, Joseph Weissenbaum crafted ELIZA, a groundbreaking computer program celebrated for its ability to engage humans in conversations, leading them to believe in the software's human-like emotions. Simultaneously, the Stanford Research Institute developed Shaky, the world's first mobile intelligent robot. Integrating AI, computer vision, navigation, and natural language processing, NLP. Shaky laid the groundwork for future innovations, serving as a precursor to self-driving cars and drones. In 1968, Terry Winograd achieved a significant milestone by creating SHARDLU, the first multimodal AI. SHRDLU demonstrated the capability to manipulate and reason about a world of blocks based on user instructions. This groundbreaking development marked a leap forward in interactive and reasoning abilities for artificial intelligence, showcasing the potential for machines to understand and act upon user commands in a physical context. In 1969, Arthur Bryson and Yu-Chi Ho introduced a significant breakthrough by describing a backpropagation learning algorithm. This innovation enabled multi-layer artificial neural networks, ANNs, surpassing the limitations of the perceptron and laying the foundation for deep learning. Simultaneously, Marvin Minsky and Seymour Papert published Perceptrons, a book highlighting the constraints of simple neural networks. In 1973, James Lighthill's report, Artificial Intelligence, a General Survey, the report led the British government to substantially reduce support for artificial intelligence research. This pivotal moment marked a temporary setback for the field, prompting a re-evaluation of priorities and approaches within the research community. In 1980, Symbolic's Lisp machines were commercialized, marking a significant moment in the AI renaissance. These machines, equipped with the Lisp programming language, played a crucial role in advancing AI applications. However, the Lisp machine market faced a downturn in the subsequent years, leading to its collapse. This shift reflected the dynamic and sometimes volatile nature of the AI industry during this period. In 1981, Danny Hillis made a notable contribution to the field of artificial intelligence by designing parallel computers specifically tailored for AI and other computational tasks. This architecture, resembling modern graphics processing units, GPUs, demonstrated a forward-thinking approach to handling the computational demands of AI processes. In 1984, Marvin Minsky and Roger Schank coined the term AI winter during a meeting of the Association for the Advancement of Artificial Intelligence. They issued a warning to the business community, cautioning that the excessive hype surrounding artificial intelligence would result in disappointment and potentially lead to the collapse of the industry. In 1985, Judea Pearl introduced Bayesian networks for causal analysis, offering statistical techniques to represent uncertainty in computers. In 1988, Peter Brown et al. Published A Statistical Approach to Language Translation, a seminal work that paved the way for one of the most extensively studied machine translation methods. In 1989, Yann LeCun, Yoshua Bengio, and Patrick Hafner demonstrated a groundbreaking application of convolutional neural networks, CNNs. Their work showcased the capability of neural networks to recognize handwritten characters, providing compelling evidence that these models could be effectively applied to real-world problems. In 1997, Sepp Hochreiter and Jürgen Schmidhuber proposed the long short-term memory, LSTM, recurrent neural network, a revolutionary architecture capable of processing entire sequences of data, including speech and video. Simultaneously, IBM's Deep Blue achieved a historic milestone by defeating Garry Kasparov in a rematch, marking the first-ever defeat of a reigning world chess champion by a computer under tournament conditions. In the year 2000, researchers from the University of Montreal published a neural probabilistic language model,